Hello everyone, I welcome you to my internship presentation, Electronic Manufacturing Solution. My name is Surya Narayana Swami, USN 1BE 19MT018, under the guidance of Mr. Suresh DB, Assistant Professor, Department of Mechatronics Engineering. External guide, Mr. Murali G, General Manager, New Tech Aerospace, Bengaluru, Sri Venkateshwara College of Engineering. Contents, certificate, company profile, about the company, task performed, product and services, subsystem services, and conclusion. This is my internship certificate. Company profile. New Tech Aerospace Private Limited, registered company under Company Act since 1999. Strong presence in defense, aerospace, and industrial segments. Design and man testing solution for customized high reliability products in analog, digital, and mixed signals power domains. About the company, Newtech Aerospace Private Limited is a well-recognized electronic company providing customized high reliability products, manufacturing and testing solutions, and customer satisfaction. Electrostatic discharge labs comply with EST guidelines as per ISRO EST 2020-21 and ISO 9001-2015 standards. Air conditioning system in laboratory have a positive pressure gradient and dust control facility, controlled temperature, humidity, and light intensity. Vision: to strive to become the leader of the industry by providing a quality services that exceed the expectation of our esteemed customer and encourage our people to prosper and grow to their full potential. Mission: to manufacture products of international standards using latest technologies and continue innovation that gives us a competitive edge to become the most sought after premium manufacturer in defense aerospace industry and expand our presence in market by being the largest manufacturer of avionic products. Military communication systems rely heavily on electronics for secure and reliable communication among soldiers, vehicle and command centers. EDA solutions are used in various stages of electronic design process, including design, simulation, verification, and testing. Embedded system design and development typically involves in system requirements and architecture, hardware design, software design, and integration, and electronic manufacturing. Task performed: architecture design, schematic capture, board layout, signal integration and crosstalk analysis, prototyping, bring up testing, and design validation, transfer to production, design validation tests. Architecture design. Architecture design of electronics refers to the process of defining the structure and components of electronic system, taking into account factors such as performance, reliability, and power consumption and cost. Architecture design process typically involves the following steps: define system requirements, determine the system components, define the system interfaces, define system architectures, evaluate and optimize system architecture. Schematic diagram. Schematic diagram is a graphical representation of electronic circuits It uses symbols to represent the components of the circuit and lines to represent the connections between them. Schematic diagrams are also used to document the design, electronic circuits, and aid troubleshooting of problems. The following common symbols used in the schematic diagrams: resistors, capacitors, inductors, diodes, transistors, and integrated circuits. Board layouts. Board layouts is also known as printed circuit boards layouts. Refer to the physical design of an electronic circuit board. It includes the placement of components and routing of electronic connection between them. Component placement, trace routing, signal integration analysis, thermal management, design rule checking, final review optimization, signal integration crosstalk analysis. Signal integration refers to the ability of the electronic circuit to transmit electronic signal without distortion or loss of signal quality. Crosstalk, on the other hand, refers to unwanted coupling of signals between different circuits or components on the printed boards. Crosstalk can cause interface and signal distortion, which can implement performance and reliability of electronic systems. Signal integration and crosstalk analysis are critical for the development of high quality, reliable electronic systems. By using specialized tools and techniques, designer can identify and resolve potential issues before circuits is building. Ensure the system meets its performance, reliability, and cost requirements. Prototyping. Prototyping is an important step in the development of electronic systems as it allows designers to test, refine their design before committing the final product. There are several methods of prototyping electronics: breadboarding, printed circuit boards, 3D printing, simulation, and rapid prototyping. Design validation and verification. Design validation is a process of verifying the electronic system or component meets its intended design specification and requirements. The goal of the design validation is to ensure the system and the component is reliable, functional, and safe for use intended use. Design validation typically involves in combining simulation, testing, analysis technique depending on the complexity and requirements of the system. Some of the important techniques used in design validation include simulation, prototyping, testing, and analyzing. Design validation is a process of verifying the electronic system and the component meets to intended design. Fabrication. Fabrication in the context of electronics refer to the process of manufacturing electronic components and systems. The fabrication process typically involves the series of steps, including design, prototyping, manufacturing, testing, and assembly. These specific steps involved in the fabrication process can vary depending on the type of electronic component or system being manufactured, as well as materials. Manufacturing techniques are used: printing, circuit boards, semiconductor fabrication, assembly, and testing. This is the key area of work sectors: aerospace and military. Aerospace and electronics include avionics, which are electronic systems used in aircrafts, satellites, and spacecrafts. Avionic includes flight management systems, cockpit displays, communication system, navigation system, and weather radar systems. These systems are vital for safe and efficient operation of air. These systems are vital for the safe and efficient operation of airspace vehicles. In military services, electronics are used extensively in weapon systems such as missiles, bombs, firearms. Electronic countermeasures, surveillance systems are also used to detect the response to threats. Military communication systems rely heavily on electronics for secure and reliable communication among soldiers, vehicles, and command centers. Embedded system design development. Embedded systems are the computer systems that are designed to perform specific tasks and integrate into devices and products. These systems are widely used in various industries, including automotive, aerospace, medical, consumer electronics, and industry automation. Em- Embedded system design and development requires specialized skills and expertise in hardware, software, and system integration. System requirement and architecture, hardware design, software design, integration, and testing. EDA solutions. EDA stands for Electronic Design Automation, which refers to a set of software tools that are used to electronic designers to create, analyze electronic systems. EDA solutions are used various stages of electronic design process, including design simulation, verification, and testing. These EDA solutions are widely used in electronic industry. Onboard computers are critical components of modern aerospace systems, including aircrafts, spacecrafts, satellites. These computers provide control, guidance, and navigation function, as well as data processing and communication capabilities. Onboard computers in aerospace application requires high level of reliability, performance, and safety to ensure the successful operation of the system. Some of the key functions of onboard computers in aerospace application include control and guidance. Onboard computers are used to control and guide vehicles during all phases of flight. Communication on onboard computers provide communication capabilities including voice, data transmission between vehicle, ground-based control systems. Power distribution packages. Power distribution packages are the system used to distribute electric power to different components and systems in industrial, commercial, and residential applications. These packages include a range of components including switchgear, transformers, circuit breakers that work together to ensure efficient and power distributions. Some of the key components of power distribution package include switchgear. Switchgear is used to control the flow of electronic power in the distribution system. Power distribution packages. Power distribution packages are the system used to distribute electric power to different components in the system in the industry, commercial, and residential applications. These power packages include a range of components including switchgear, transformers, circuit breakers, and that work together to ensure efficient and reliable power distribution. Some of the key components of power distribution packages include switchgears, which is used to control the flow of electric power in the distribution system, power cables, which are used to connect different components of the power distribution system, including transformers, switchgears, and circuit breakers. Power distribution packages are used in a wide range of applications, including power generation, transmission, and distribution, as well as in industrial and commercial facilities. Analog digital sensors. Analog and digital sensors play a crucial role in aerospace applications, providing important information about the environment and the performance of the aircraft and satellites. These sensors are used to measure wide range of parameters including temperature, pressure, acceleration, velocity, and position. And analog sensors provide a continuous output signal that varies in response to change of measured parameters. These sensors are often used in applications that require high accuracy the, and resolution, such as in-flight testing and research. Some example of analog and digital sensors used in aerospace application include strain gauges, accelerometers, pressure sensors, gyroscopes, magnetometers, GPS receivers. Conclusion: the company also helped me with the exposure to the industry, hereby gaining the knowledge and improving my confidence and facing challenges in the work environment. Thank you.